everyone, welcome to this Math 082 video. This is section 4.4 where we learn about special products. In the previous videos we've established a general factoring strategy. Our general strategy is to first look for and factor out the GCF. Then we ask ourselves how many terms our polynomial contains. In 4.2 we learned that if it has 4 terms we need to look at grouping. If it has 3 terms we can try the AC method. And this time, in this video, we're going to learn about difference of squares, which is applicable if our polynomial has 2 terms. So we're looking at a difference of 2 squares. By definition, a difference of 2 squares looks like this: a squared minus b squared, and it factors into a plus b times a minus b. Notice that if we have the same thing joined by addition instead of subtraction, if we have a squared plus b squared, that is prime. Generally speaking, a squared plus b squared cannot be factored. So let's look at this first example. In chapter 3, we worked with problems like this, where we had x plus 2 times x minus 2. And we learned to use FOIL, first, outer, inner, last, to expand this. We also discovered that when we have identical binomials but opposite signs, that the inner terms cancel out, leaving us with 2 perfect squares that are being subtracted from each other. Okay, so this is called a difference of 2 squares, or simply a difference of squares. So before we proceed to the first example, let's think about which of these different terms is a perfect square. Well, x squared is x times x, but x to the 4th is x times itself 4 times, which can then be written as x squared times x squared. So it also is a perfect square. Likewise, x to the 8th is x to the 4th times itself, and x to the 64th is x to the 32nd times itself. Therefore, we say all variables with even exponents are perfect squares. Here's our first example. So let's go through our procedure. The first thing we look for, remember, is we ask ourselves, what is the GCF? If you want, you can pause this video before I proceed and see if you can figure out how to factor this before I do. So in this case, the GCF is 1, so then we have to figure out how many terms that we have. Okay, we clearly have 2 terms in this polynomial. The only method that we've learned so far is difference of squares. So we ask ourselves, is x squared a perfect square? It is. Remember, x squared is x times itself. How about 16? Is 16 a perfect square? It is. It's 4 times 4. And the last thing we need to make sure of is, are these 2 perfect squares being separated by subtraction? And they are. Therefore, we can factor this using the definition of a difference of squares. So what goes in here, in our first space, is the square root of x squared, which is x. Then in our last space, we have the square root of 16, which is 4. The last step is to fill in a plus on one side and a minus on the other. The order does not matter. Let's keep going. For this next example, we want to find our GCF. Again, pause this if you want to do this without me. So our GCF in this case is 1. And again, we have 2 terms. Are they perfect squares? Well, let's think about it. What's the square root of 9a squared? Well, the square root of 9 is 3, and the square root of a squared is 3. How about 25b squared? Well, the square root of 25 is 5, and the square root of b squared is b. So these are both perfect squares. Are they also being subtracted from each other? They are, so we can proceed to use the definition of a difference of squares. So in our first spot, we're going to put 3a. In our second spot, we put 5b, and then we make sure to separate them, one with a plus sign, one with a minus sign. Let's keep going. Okay, so in this problem, again, the GCF is 1, and again, we have two terms. You can see clearly that x squared is a perfect square, and 36 is also a perfect square. Then we have to ask ourselves, are they being subtracted? Well, they are not being subtracted, they are being added. So this is a sum of two squares, which means that this is prime. Because it is not being, the two squares are not being subtracted, there's nothing else that we can do.